Okay, so for innovation, the state of C++ interop. That's a bit of an ambitious title. So it's more going to be about a story that I lived for the past 4 years. For the past 4 years, I was working in a company called BPFK in South Korea, hence the title. And we use a lot of C++ interop. So before we start, I wanted to mention that views are my own. They are not related to my past employer, BPFK, or my present employer, which is Symmetry. So why did BPFK choose to use D? Actually, they didn't really choose to use D in the first place. They chose to use Go. They wanted a strongly typed programming language, so Go was fitting the bill. They wanted something they had modularity with, but something that was missing is the C++ integration. And that C++ integration became very important because our project was built. Our project used as a central component a C++ library. Called SCP, for the Stellar Consensus Protocol. And so when the project started, since the team originally wanted to use Go, we started to re-implement that consensus protocol, which is 15,000 lines of code plus test in Go. And it was quite complicated code. It was a consensus protocol. It was using the standard library a lot. And it didn't go so well, pardon the pun. So when I joined the project a bit after it started, and after probably a month, I was a bit frustrated because I saw the team spending a lot of effort developing with Go, and all I could think was, this would be so much simpler in D. There's just so many advantages in doing it in D. So I decided that I would spend a few hours every evening binding the C++ library, the core in D, and it was just the public API. So it was probably less than 1,000 lines of code that I thought I needed, and I estimated it would take me 2 to 3 weeks. You know what they say about like time estimation in software development, right? You never get it right. Well, I got it right. It only took me about 3 weeks to bind the C++ library after I spent 3 months fixing the bugs in DMD. But only 3 weeks for the C++ library. So it was a great success. So I did the bindings, rudimentary bindings, and I went to my CEO and I said, oh, look, it's only 3 weeks of work. Pretty simple, one-man project. And we have a core we can start to work with, and we don't have to rewrite everything in Go because we were not even 30% done at the time. And my CEO liked it so much that, yeah, we switched to D. So it was a great success, and we never looked back. Because in addition to the amazing C++ integration, which I'm going to talk about today, there's other qualities of D, so the strongly typed programming language, and very important for me at the time, and something that worked very well for us, D is very plastic, as John noted. So it's extremely easy to try new approaches, experiment a bit, especially when you have unknowns in your project. You try an approach for a week, 2 weeks, and then if it doesn't work, well, you just throw it away. But if it works, you want to turn that into production code. And in D, it's very, very easy. You have static for each for boilerplate. You have the GC, and optimizing that is simple. So yeah, I started by prototyping Agora, and that worked fairly well. So when I was preparing that talk, I tried to make a list of the feature, the C++ feature that D supported. And I was mostly looking at pre-C++ 20, because we didn't touch anything C++ 20. So C++ 11, 14, and 17 mostly. And the list I came up with when I looked at the documentation was quite incomplete, but then I looked at the implementation, and I came up with, yeah, pretty much everything. So obviously, class, struct, reference pointer, and so on, that we support. But we can use templates very easily. We can use operator overloads. The website, if you go to the website, the language documentation, and you look at C++ integration, it will tell you that we don't support operator overload. We can call constructor and so on. It's wrong. The person that implemented that forgot to update the documentation. Thank you, Manu. So we support every operator overload as far as I could see, even the stream operator, assignment and everything. Thank you. Yep. The only thing that is not supported is concatenation assignment, because there's no such thing in C++. And you can even throw exception from C++ and catch them in D. Or you can throw std exception derivative in D and catch them from C++. We didn't do that, but you are supposed to be able to do it. So how did it go? We had a fairly simple architecture. Obviously, that's overly simplified, but we use Dub as our build system, because it's the standard build system for the D ecosystem. So we decided to use Dub. We had our, the common source directory with Agora, which is the name of the project. You can find it on GitHub, which was the root package for the server. And then we had scpd and scpp. So scpd being the D bindings for scp, and scpp being the CPP code for SCP. Naming wasn't very hard. So how did we build? Fairly simple. We had a pre-generate command. Because we love D, we decided to make a D script that would build all the C++ code. There's no way around having something that builds your C++ code. We wanted to be cross-platform. We later dropped compatibility with Windows for unrelated reason, Fiber's issue. But the script could support all three platforms, macOS, Linux, and Windows. So we had TIS, and it was just essentially a glorified makefile. The magic trick was, I think there's a pointer? Yes. The magic trick was TIS. It was adding the object file actually to the source file. And this way we ensure that the compiler the Dub just gives it to the compiler and everything just worked. So we had to do it for object. There was a few bugs to fix in Dub as well, but we got there. And then, well, you need to link the C++ standard library. Can get around that. You probably want to pick the C++ standard you're using. Nowadays, by default, we're using C++ 11. And when the project started, we were using C++ 11. We updated to 14 and now to 17. We never really had a problem with changing version. The main problem we had at the beginning was TIS, because there were quite a lot of changes happening in libc++ when C++ 11 came around, and D wasn't ready for that. Nowadays, D is ready, but at the time it didn't work, and that was a very easy workaround. So I think nowadays we could remove it, just didn't have the motivation. So obviously, you need to know your target. There's three version identifier which are defined by the decompiler whenever you compile. We also have version identifier for C runtime. You might be familiar with those. And we have the CPP runtime for Clang. So if you're compiling with Clang++, you're going to get this. If you're targeting Clang++. GCC, and Microsoft. I think it's fairly self-explanatory. For a long time, we didn't have the possibility to manually define tools. They are reserved by the compiler. But that has been fixed a few months ago. So what does it look like? That's really the simple stuff. So you have extend C++ in front of something. It can be a struct, a class, can be a function. And so up there, you have the D code, right? So you have a struct, and then you can pass it by ref, and it looks like this. It's very simple. You have your, you can pass it by pointer, you can have a pointer to pointer, and you end up with tools declaration. There's a few tricks in the Mangling that actually makes the experience more pleasurable. For example, if you take, so in D, const is transitive. All type constructors are transitive. So technically, const pointer to foo should be written like this. Foo, const, pointer, const. Because the pointer itself is const. C++ Mangling actually strips out the outermost const, because it's not relevant. So tools to declaration are equal, and they mangle to the same thing. And D is smart enough to understand that, and it will mangle this to this. But if you have more than one level of constness, you have to be cautious about putting all the consts where they belong. Luckily, C++ has mangling, so if you make a mistake, the linker will tell you. But this actually brings us to the most important slide of this presentation. If you only remember one thing from this presentation, that it be this slide. If it's D code, you have to approach your binding with a D mindset. You can't approach it with a C++ mindset and then just write D code. It will not work. I tried. It didn't work. One example of this is namespace. So unfortunately, in D, we have two ways to represent namespace. The first way is like this. So you have the command extend C++, and then you can have alias sequence of string. So tuple of string. And so it is awesome func is in the namespace dlang colon colon awesome colon colon app. Fairly simple, right? But you also can do it this way. And this is clearly the less awesome version of doing it. So when should you use the first way, and when should you use the second way? The answer is always never. Don't do it. Not a single time. I haven't found a single usage where I wanted to do that. The main difference is that you can refer to the symbol using the fully qualified name, as you would do in C++, and that should be your red flag that you shouldn't do that. For example, if you can define a symbol in the same namespace in different modules. Because for the compiler, it looks like less awesome is defined inside a struct, well, a struct. It's not exactly a struct, but it looks a bit like this. So when you try to define two functions for the dlang namespace in different modules, then the compiler will complain. It say, oh, I find the dlang symbol in module A and in module B. And you end up writing code to these ambiguities, which you wouldn't have the problem with this. So not even once. Namespaces are a bit smarter than just an alias sequence of string. We can actually take any expression that is CTF able, like most things in D. So we make, in this case, we make use of our awesome CPP runtime Clang, because from some version of Clang, I don't remember which one, but they started to use an inline namespace to implement new features. So an inline namespace from the D point of view, it's merged into its parent namespace, but from the C++ point of view, sorry, is merged into its parent namespace. But for mangling, it's mangled using the full name of the namespace. So when you have a symbol inside std namespace, like =, it will be mangled to std__1 =, but you can refer it from C++ code as std =. And for other runtime, or actually before a certain version, I think, everything is in std. So we have the ability to do that since 3 years, I think. Because before doing this, we needed to use very large mixins, and it was not enjoyable. You notice that we have parentheses here. And the reason we have parentheses is to tell the compiler that this is an expression it needs to evaluate, and it's not this terrible thing that we never want to use. Otherwise, it thinks we want to use the identifier version, and I don't know how to tell DMD I never want to do that. So yeah, mind the parentheses. And I'm hoping, Walter, we can have a talk about deprecating this, so we make the code a bit better. So my approach whenever I was binding code in C++ was to keep it super simple. The first step is always to match the mangling. It needs to have, the compiler needs to mangle to the right thing. There's not many ways around this. The compiler should do the right thing here. And as soon as you match the mangling, like I did here, sometimes you don't need to do anything else. Like =, is just a template parameter that is passed to a map and to other container. So I don't really mind what is inside, and there's probably nothing inside. But the second step would be to match the vtable and the offset. So I can call the right virtual function, and I can access the right member if I access a member of my struct. Then it's to match the size, so I can construct array, maybe even pass things by value. And the final boss is always a lifetime function with constructor, destructor, copy constructor, and move. I usually don't win against this guy, but there's very easy way around it. Luckily, I wouldn't be here today otherwise. So an example of pair that does the right thing is pair std namespace with the template parameter, and just the two member. So we match actually we match the mangling, the offset, and the size, and we just don't match the lifetime. So the way around the four properties I mentioned, mangling the compiler really needs to get that right. If it doesn't, that's a very high priority bug, because it's going to ruin your life. Because we use template parameters, it's really hard to walk around that using pragma mangle. You can, but it's just really hard. For vtable and offset, usually just write some tests. It's fairly easy, and you write them once, and it just works. That's what we did for our binding for SCP. We wrote some tests. We did some improvement over the year, but essentially they are the same tests that we had from the beginning. And for the lifetime function, pass them by reference pointer, make little wrapper, which is essentially the same thing. It's going to save you a lot of time. Just pass things by reference. So when you test the size, that's what we do. We have a static for each that generates just a bunch of declaration here. Obviously, we need to have the matching declaration on the C++ side, which returns the right value. So the C++ side is actually very ugly with lots of macros. But on the D side, it's clean, as usual. So we define for all the glue types, we define this thing. and then just a for each at runtime, which calls a function. The function returns the size. We check that the size is what we expect. If it's not, we print a message. And every time we update the library, the test run, it catches an issue from time to time, but that was really that really allowed us to progress without much worry. Testing the layout is a bit more complicated, but not much. Same approach. We define a field info because we need the size of the member and its offset compared to the beginning of the object. And we again define the CPP field info. We give it the type, and it returns us the type and the name of the field, and it returns us the right value. And it looks like this. Likewise, for each over type, then for each over all the member. Thank you, D, for reflection. And we get the value, we compare it, and we print a rich error message. You can try it at home. So an example of the approach of wrapping things is STD map. That is very simple STD map binding I've made. You need a constructor, which returns you a pointer, because you really don't want to pass it by value if you don't have the right definition, the right lifetime function. And that wouldn't fit on this slide, or 5 of them. So just return it, and it's also allocated on the C++ side, so you don't really worry about it. If it has pointer, you should technically register things, but I wanted to keep the side short. Operator subscript, I guess, which, thanks to Manu, works very well. And then instead of or assign, which is essentially a op assign, which we can't really represent in C++. In D, we have the ability of we have a separation between op index that does assign and doing the first assign. That's a great thing. But we can't really represent that in C++, as far as I know. So I had to use this little trick. And then the STD map inside. So your best friend ever is this statement: explicit template instantiation in a C++ file. It's a bit low, sorry. But yeah, template struct map with the template parameter. That will generate an instantiation of your template inside of your CPP file. Since you compile your CPP file and you link it with your D file, you will have all the things available for the linker, and it will just work. The thing that will not work is the functions that are inline, usually. Some accessor, there's quite a few things that are inline, especially with vector. So tools you will need to provide a definition in D. But usually you can just forward to other things that exist in the aggregate. And on the D side, it just looks like this. So you define your extend D op index assign, which is the right D thing to do. And then the tree binding here. And you can, as long as you use it with two arguments, so pointer to a const char and an integer, it will work. Everything will just work fine. So if someone tells you, oh, I can't use D because of the GC, you say, well, you don't need to use associative array. Look, a couple lines of code, it works. You can use a standard C++ library. You don't even use a GC. Right? So how it should actually look would be a bit better if you could just look this way, you know? You include map, you instantiate it, and then you could import some module that gives you all the binding, and likewise, you define an alias, and you use that alias. We actually have something like this. It's missing 2 characters, stdcpp binding. So in DRuntime, in core.stdcpp, we have binding for quite a few header of the C++ standard library. Once again, thanks to Manu. It's a lot of code. Well, I think a few people, right? Guillaume Piola also?
Pretty much me.
Okay.
A lot of work.
Okay, Manu is the man. We have, so we have quite a few bindings. We have vector, we have allocator, string view, and so on. But having them in DRuntime is a problem. It's a problem because since we ship DRuntime built, we tie the user to a certain runtime, a certain CPP runtime. So one thing that was agreed at the last meeting with the foundation was to separate it in its own dub package. But I will put all the CI in place, don't worry. So we will move it by the end of the year, I hope. So as I mentioned, yeah, we have many modules, many building blocks, but we don't have map. If you feel like contributing again, Manu?
I thought I did map.
What?
I thought I did map.
Well, maybe it's not merge.
Maybe I rage quit before I committed. I've probably got a nearly finished map somewhere.
Okay, then don't rage quit again. Come back. I'm very happy to merge it. Right, so the C++ wrapper code I mentioned, you will need it anyway. You need to have C++ file that you compile. Even if you decide to link with a shared library that is distributed by a vendor, you will at some point need to have template instantiation in any reasonable code base. So it's really your most powerful ally to have this little piece of C++. And it allows you to take out all the weirdness of the code you potentially are interfacing with. Because we were lucky. The code we interfaced with was good code. It was essentially D code written in a worse language. But, not bad-mouthing the other languages, sorry. But sometimes you will have things that you can't deal with. You will have a head const, right? Pointer that is const, but then the thing it points to is not const. And for D, you cannot interface with that. You need to tell D that this is mutable. So you write a little function that takes it as mutable, and you call the C++ function, and everyone is happy. You present D with the D interface, and you can match the mangling of the C++ function. If things throw an integer, for example, you can catch it, wrap it in a std exception, and then rethrow it. Because if you try to catch an integer from D, I actually don't know what happens, but I don't think it's good. And anything where you can't handle the lifetime, you just pass it by ref. It's usually 2 lines. Another thing you can do with C++, with the Interop, and that we started to do, I think after a couple of years, was gradually replace our functions or C++ code with D code. It started because we needed to remove some dependencies. There were some minor piece of code that was bringing in large dependencies. Namely, some debug code was putting in a full JSON library, just to print a few things that we weren't even using. So since it was in the, we had the header file with the function definition, the declaration, and then the definition in the CPP file. So what we did is we just removed it from the CPP file, and instead we implemented it on the D side, in its own D module. And the linker just happily picked it up, linked it in place, and we got rid of the dependency. So we started off getting rid of these dependencies, and we realized it was working very well. It was very easy. So we used it for things we needed, like replacing the hashing algorithm, replacing the signature algorithm, and then we started to replace data type. Because as long as we were matching the binary layout, it was working. So there was the hash type, we extended it, and we just provided a static array that was wrapped in a structure, and everything was working fine. On the D side, we had a much better API, and the C++ side didn't complain. And in my opinion, this is extremely powerful. you can take more C++ code base and start to, you extend your build system to a D, then you can gradually replace things, make your code easier to read, isolate things, and that's, as John mentioned, really the power of D. So here I listed a few features that were implemented in the language for C++ integration. So choose one, obviously, are obvious. We had extend C++. Sorry, I forgot to mention that. Many things in the standard library are declared as a class or a struct. And for C++, there's just one minor difference between a class and a struct. It's the default protection. Except on Windows, where the mangling is different. So for the sake of Windows, we have the ability to give extend C++ class or struct to say, OK, map is a value type, but it's declared as a class inside of the header. So mangle it as a class, but it's really a value type. So we declare it as a struct on the D side. As I mentioned earlier, the namespace using, OK, this doesn't exist, just using expression. We had to implement ABI tag, the new ABI tag, to bind to a std string, because it affects the mangling. Pragma mangle with str or dec or str to allow us to bind to std function. And those might seem a bit off. So copy constructor and copy constructor is something that, if I'm not mistaken, one of the impetus for it was that we couldn't bind to a std string. Because since GCC G++5, std string uses an interior pointer. And D doesn't like interior pointer, right? By the spec, things can be moved around however you want. Well, however the compiler wants. And that doesn't work for C++. That didn't work for me. And for a few people. So we got copy constructor. Also, the plan is to deprecate postblit. But I don't think we acted on that plan yet. But last I checked, it was to deprecate, the plan was to deprecate postblit. So we got copy constructor, which are supposed also to prevent moves without a call to the copy constructor. LDC and GDC usually do that. DMD doesn't agree. So that's one feature of the language that affects the whole language in a positive way. That was for C++ integration. We switched to dwarf exception handling. When the work on C++ integration started, D had a different exception handling mechanism. And thank you, Walter, for switching to dwarf, because it also made debugging much easier. I think it's a bit less efficient, but it's much easier to debug. And finally, traits get target info with we have a few strings available here, which allow you to get information on the C++ standard you're targeting, the C++ runtime, and I think there's a few other things that are not C++ related anymore in there. So what worked for us at BPFK is that first we got lucky. We had to interface with good C++ code, not bad one. So we could pick up the right habit. We went straight to add C++ code in between D and the actual C++ library. And that made everything so much easier. And it was written by hand. It was not generated. It was just written once and usually not touched. Using explicit instantiation, avoiding lifetime. And we implemented preview in because, well, Mathias touched a bit on this today. But there's a lot of things that just don't work if you have immutable or const things, or if you have non-copyable, non-movable aggregates. And we really wanted to pass things around. We ended up passing our C++ aggregates to vibd, and vibd would just serialize it to JSON and send it to another server. And it worked. It was a bit crazy, but it worked. We had a binary deserializer, which we made very sure would not make any copy, so it wouldn't corrupt the strings. And all of this worked, but it worked thanks to preview in, because we could pass things by const reference, and we could pass error values. So I'm hoping it will become the default as soon as I fix one other little issue I found.
It will. It will.
Thank you. And the last thing, unfortunately, was to not use DMD. Because the main difference between GDC and LDC, GDC, and DMD is that DMD passes things by value, even if it has a lifetime function. So it calls a lifetime function sometimes. LDC and GDC will just go and pass things by pointer, hidden reference, as soon as there's a copy constructor or destructor and so on. And so we avoided many of the bugs that we would have hit otherwise by just using LDC all the time. But since the project started, DMD got much better. A lot of bugs were fixed. So I would give it a shot nowadays. But if it doesn't work, I just go back to LDC. And that's me. Walter.
Yeah, sorry, Walter wins that one. We got a question down here too.
This is really fantastic work you've done. And
Thank you.
on the DLang documentation site, there's a page called Interfacing with C++. And that was written like 15 years ago.
Yeah.
And I would really love it if you could take your experience, modern experience with this, and just chuck that page and write a new one. I think you could do a far better job than that old one's in there. You got a lot of great ideas and insight in it, and I'm sure what you could do would be very helpful.
Can we post a YouTube link? No, it's on my to-do list. It's on my to-do list since a long time, and I probably should get to it.
So you mentioned that structs and classes, we can specify what it is on the C++ side.
Yeah.
Are we flexible about what it is on the D side? Like, can we tell D, extern C++ class to a D class, extern C?
Yeah.
Okay.
So when you look at your aggregate, you consider, does it have value semantic or reference semantic? Most of the time for the containers, it has value semantic, but they are declared as class in the header. So I went with struct map and then extend C++ class. If it was something with reference semantic, actually in our bindings we had a lot of classes that were actually classes. So it was extend C++ and then it was a class. But if we had something that was defined as a struct, we could do that as well.
Yeah,
So
SFML has both, so it's
Yeah.
that's kind of an important thing.
But you approach it from the point of view of D. Like, what's the semantic of it? Is it value or reference? And then you just make the mangling match. Yep.
No. Sorry, I've got it already. I'd just like to thank you for doing this talk, and it's really nice to see all of this put together in a concentrated way. There's a ton of work there.
Yeah.
You mentioned, I'd also like to echo Walter, it'd be really, really great if you could update the docs to be modern. I'm totally lazy and didn't do it at all. You mentioned before that you were using exclusively ref and pointer, and that was sort of the thing for a long time, but I feel like I painstakingly worked through copy and move constructors to the point where they worked, and passing by value and lifetime management did actually work reliably for at least my tests. I'm curious to know if you tried them out and where you fell over.
so I started to prepare this talk around 2 months ago, and I started to write the slides around 1 week ago. The rest of the time was spent trying to enable things in DRuntime. So there's still a few issues. I don't know if the bindings were not fully correct, or if it's still, yeah, I had the problem mentioned with DMD that sometimes it still gets moved. I think I have an issue for it. I believe it worked with LDC. But I need to write the slide at some point. But hopefully, we can move things to another repository and write a proper CI that tests on all 3 platforms and all tests under all standard version. And then we see what works and what doesn't work. That's my long-term plan. Well, middle-term plan. There's a lot of tests to enable here.
I think he's first.
I don't know, so which version of LDC did you use? Because, so I had 2 issues. First, exceptions don't work for me. Yeah. So they don't get caught, they just abort C runtime. And second, the std string didn't work. I found all that comments about interior pointer. So you're saying that there is some feature now in the language which makes it work, but I mean, so does it work or doesn't it work? Because I see in your dub file that old CXXAB declaration with which it will work, but it means you have to compile C++ runtime library yourself. So with that old define. So if you use the one, for example, from Debian or whatever, it's compiled with a new AB version, and for me, it didn't work. So what's your experience?
You don't have to compile the standard library yourself, because that define is taken into account when you instantiate the template. So if you do an explicit instantiation in a C++ file, I believe that you'll get the right layout.
How is that possible? Because C++ library that I'm interfacing expects some layout of std string from the C++ standard library, right, already?
Because it has a dual ABI, so actually both of them are compiled into the standard library.
Okay, so my understanding that std string implementation, there was one implementation previously, and there is another one now.
Yeah.
And that's reflected in ABI precisely because it changes the compiled layout of the class, of std string class. Yeah. So you cannot just change it at linking time.
I might be able to answer
because of inline namespace, right?
It's the inline namespace. Yeah. I think you'll find that, well, firstly, most of it's instantiated in the client code. Most, like libc++ doesn't have much hard code in it because it's all templates. The stuff that's not templates has this inline namespace __1 on the modern ABI, and both ABI's non-template code are present in libc++, lib standard C++.
So you are saying if I add that tag to dub file, then it should work?
Yeah.
Okay,
so if you add the define in the dub file, then you only bind to std string. If you don't have the define, you bind to std__1 string.
Can you show your dub file?
It's a trimmed down version, but
yep. But so extern standard C++17, there's magic there that will enable the __1 mangling, depending on how you define that. So if you don't define that correctly to match the C++ compiler, you'll get link mismatches.
And the other question was?
STD exception, basically.
Right. So exception, when we started the project, actually, we were missing the definition for macOS, and most of our developers were on macOS. So we decided to just catch it in the C++ code directly. And we didn't actually try to have exception crossing boundaries. It should work, but I haven't tried it. So send me the bug reports and I can take a look at it.
Okay. Okay, got it. Thank you. I guess I will just add my vote to updating the documentation because, yeah, kind of discovering all these small magic things that you have to do, or like do it this way, not that way. Use the pointers. That was very helpful. But yeah, I mean, all in one place. Like just share the slides. That would be very nice. Thank you.
Sorry, my bad.
Yeah.
Yeah, I have another request or work for you to do. Sorry about that. If Bugzilla doesn't have a CPP keyword, it should have one. And every time you run into an issue, please post it on there. And you don't have to fix it, just post it on there and we can just knock them down one by one.
Yep, I'm trying to. And I think it does have a CPP issue. But yeah, every time I find an issue, I post it here. We also had a very sizable issue in our company GitHub, which listed all the bugs we encountered with D. I can send it to you if you want. But most of them have been fixed.
It's probably worth noting, just for the live stream, anyone who doesn't know, that if you compile with link time optimization, you can also basically eliminate all the overhead. If you end up having to go through like a helper function, for example, to something tricky in C++. So you can have like decode, which has C++ functions inlined into it. And in fact, GCC can also do static analysis across the language barrier. If you're one of not many people actually using GCC in production, sorry, in GDC in production.
Okay.
That's more of a note than a question.
That's good to know. I was just trying to make my life easier, not harder.
All right, I think that's about all the time we have questions for. So thank you again, Mathias.
Thank you.